Hello students, in this video we'll see how Gaussian elimination can be used to put a matrix into reduced row echelon form and to determine if a system is consistent or inconsistent. Let's consider the following system of equations. Let's consider 2x plus y plus 2z is equal to 1. Then negative 2x plus 2y plus z is equal to, let's say, negative 1. And then finally, let's say x plus 2y minus 2z is equal to positive 1, right? So let's look at this system of equations over here. I have three equations, three unknowns, and so let's put it into its augmented matrix form, which would be a 2, 1, 2, a 1, and then a negative 2, and then a positive 2, and then a 1, and then a negative 1 over here, and then finally a 1, a 2, and a negative 2, and a 1 over here. And so what Gaussian elimination tells us to do, Gaussian elimination tells us to put all the 0 rows in the last row. So step one, so first step in Gaussian elimination, put all 0 rows on the bottom. Okay. There are no 0 rows here, so there's nothing to do, right? And typically, that's sort of the trivial step, is put all the 0 rows in the bottom. Because what will tend to happen is that if you have all 0 rows, it won't tell you any other useful information, right? 2, starting with the first lead coefficient, with the leftmost lead coefficient, 0 up below it. Okay, great. So that's easy to 0 up below. So what I'm going to do is the first operation I'm going to do over here. The first observation, I'm going to do a row 1 plus row 2. If I do row 1 plus row 2, that will 0 out this second entry over here, right? So the first row will stay the same, 1, 2, 1, and then a 1. And if I add row 1 to row 2, I'm going to get a 0 over here. I'm going to have a 3 over here, and I'm going to have a 3 over here, and I'm going to have a 0 over here. The second row stayed the same. And then what I can do now is let's do it like this. Then I'm going to simultaneously do another operation. I'm going to simultaneously, to save myself some space over here, I'm going to take the third row, I'm going to replace the third row by 2 times the third row. So 2 times the third row will give me a what? Will give me a 2, then a 4, then a negative 4, and then a 2 over here, right? So you just replace the third row by 2 times the third row. So these are elementary row operations. Good. And then what I'm going to do is I'm going to try to 0 out that 2 over there. So I'm going to do negative 1 times row 1. So I'm going to do negative 1 times row 1 plus row 3. So row 1 stays the same. 2, 1, 2. And then what? And then 1. And then the second row stays the same. Then a 3, then a 3, then a 0. And then I'm going to do negative row 1 plus row 2, that's going to turn that into a 0. I have a negative 1 plus 4, that's going to be a 3. And I'm going to have a negative 2, and then a plus 4, that's going to be a negative 6 over there. Great. And then I have a negative row 1, and then a row 3, so that's a negative 1 and 2, that's going to turn into a 1 over there. All right, excellent. And so now what Gaussian elimination says continue on with this procedure. So that the next lead coefficient is this 3 over here, right? And so then keep going. Continue this procedure, continue with next rightmost, I guess leftmost in this case, like leftmost lead. And then this eventually will terminate, right? So my next lead coefficient over here is just going to be this 3. Now I could scale this to get a 1 over here, and eventually we're going to scale to put 1s everywhere to make our life a little bit easier. But since these coefficients worked well together, I prefer just to multiply and then do the fractions at the very end. Okay? You can do either way though. It won't change anything. Okay, so I'm going to do what? I'm going to replace row 3 with negative row 2 plus row 3. And what we get if we do so? Well, the first row stays the same. The second row is going to stay the same, 0, 3, 3, and then a 0. But now the third row gets replaced with what? It's going to be a negative 3, and then negative 3 what? Negative 3, and then a 3, that's going to give me a 0. And then negative 3, and then negative 6 is a negative 9. And then a 0, and then plus, there's nothing's going to change with that row 3. I'm just going to stay at 1 because there was a 0 over there. Great. And so now what I have over here is now I have a situation where I'm in great shape, because what I'm going to do now is I'm going to put this into reduced row echelon form by doing what? I'm going to change all three of these equations to put 1 as the lead coefficient. So I'm going to make the lead coefficient 1 by doing what operation? So now we're going to make the lead coefficient equal to 1 by doing what? By doing 1/2 of row 1. So our operation over here is going to be this CL operation is going to be a 1/2 of row 1. And we're also going to do what? We're also going to do 1/3 of row 2 and negative 1/9 of row 3. Great. If we do so, what we get, the first row is going to change into what? So I'm doing 3 operations simultaneously, right? I'm going to get a 1, then a 1/2, then a 1/2, then a 1 rather. Great. And then a 1/2. 1/2. And then what we get if we do a 1/3 by row 2, I'm going to get a 0. Then I'm going to get a 1 and a 1. And then I'm going to have a 0 over here. And then finally, if we do a negative 1/9, I'm going to have a 0, 0, and then a 1, then a negative 1/9 over here. Great. And so now what I can do is I can put this into reduced row echelon form, starting at the rightmost thing and working my way up, right? So then start with rightmost, lead 1, and 0 out the above. Okay, great. So let's do so. So I'm going to do negative of row, if I do negative row 3 plus row 2, let's do negative row 3 plus row 2. So row 3 is going to stay the same. And of course, I can also do negative row 3 plus row 1 simultaneously. That will zero out that thing over there too. So let's do these in order, right? So what will we do if we get negative row 3 plus row 2? Nothing, nothing over here, right? So it's going to be a 0, then a 1. That's going to stay put. This is going to zero out. Then I have positive 1/9 plus row 2. So that's going to be a positive 1/9 over there. Great. And then what will happen over here? If I do negative row 3 plus row 1, what we're going to have is we're going to have a 1 up here. Nothing changes over here. And then we have a 0 over here. And then what we'll have is we're going to have a negative 1/9 plus a half. So let's do that over here. So we have to do a negative 1/9 plus a half. So negative 1/9 plus a half is what? So negative 1/9. So positive 1/9 plus 1/2 is going to be what? It's going to be 2 over 18 plus 9 over 18, right? And so it's going to be 11 over 18. 11 over 18. And this is where the fractions get a little bit messy over here, right? Okay. Great, and now the last step over here to do is the following. So I'm going to do negative of row 2 plus row 1. So if we do negative row 2, negative row 2, actually we got to do 1/2 of row 2, right? Because there's a 1/2 up there now. So I got to do negative 1/2 of row 2 plus row 1. What will we get? Row 3 is going to stay the same, 0, 0, 1. Negative 1/9. Row 2 is going to stay the same, 0, 1, 0, 1/9 over here. And then what will the top row become? This part is going to be the easy part. Well, there's nothing here and nothing here, right? So that's going to be a 0 over here. Excuse me, a 1 over here, nothing over there. So that's a 1 rather than a 0. So 1 and a 0. And then 1 over here, I'm going to get a 0 over here and a 0 over here. And I got to do negative of row 2 times 1/2. So that's going to be a 1 over 18, right? So that's going to, this term over here is going to turn to a 1 over 18. 1/2 of row 2. And then plus, that's negative 1, excuse me, so yeah, so that'll be a negative 1 over 18 plus 11 over 18. That's going to turn into a 10 over 18. 10 over 18, right? And of course, 10 over 18 can be simplified, right? That's going to be 5 over 9. 5 over 9. So this is going to be 5 over 9. Okay, great. And so now what does this augmented system tell us over here? So let's read what this augmented system tells us. This third row tells me that z is equal to what? Z is equal to negative 1/9 over here. What's my y going to be equal to? My y is going to be equal to positive 1/9. And what is my x going to be equal to? My x is going to be equal to 5/9 over here. So it looks like x is 5/9, y is 1/9, and z is 1/9. That tells me that this system over here is consistent. So the system is consistent. Okay, so that's how the method, that's how using elementary row operations it can work and turn any matrix over here into a matrix that's in a reduced row echelon form. This one had to be particularly nice because we get what's known as the identity matrix over here, and that automatically implies there's going to be exactly one solution to the linear system. Now, of course, I could have potentially had some free variables in here. I could have had an inconsistency. I could have, for example, had a 0 in my last entry over here. Then the system would have been inconsistent, right? So there's lots of ways for the system to be inconsistent, and there's also lots of ways for the system to have sort of more flexibility in the solutions. So in this instance, we got exactly one solution to the linear system, and that proves our system is consistent using Gaussian elimination. Thank you very much.